Ethernet LAN switching, presented by Mike Gonzalez. Today I'll attempt to explain how switches learn where devices live, forward frames accurately, avoid collisions with full duplex, and use VLANs and filtering to keep the traffic clean. So what does a LAN switch do? LAN switches connect devices in a local network. A LAN switch links together computers, printers, and servers so they can share data and resources inside the same network. Switches forwards data as Ethernet frames to the correct destinations. The switch examines incoming Ethernet frames, checks the destination MAC address, and forwards them out the correct port so the data reaches the intended device accurately and efficiently. Switches improve speed and efficiency over hubs. By managing data flow intelligently, switches make networks faster, more secure, and more reliable for everyday business operations. Why does switching exist? The reason switching exists is to reduce network traffic. Switching prevents data from being sent to everyone on the network, keeping communication focused and efficient. The use of switches improves speed and performance. By sending data only where it needs to go, switches make networks faster and reduce congestion. Switches in a network allows multiple conversations at once. Switches let many devices communicate simultaneously without their data colliding or interrupting each other. Switches are smarter than hubs. Unlike hubs, which broadcast data to every connected device, switches identify where each device is and send data only to the correct destination. A switch learns by automatically building a list called a MAC address table. This is also known as a switching, bridging, or CAM table. This table keeps track of which devices are connected to which ports. When a device sends data, the switch notes its MAC address and the port it comes from, storing that information for future use. Over time, the switch becomes smarter, sending data only to the correct destination instead of broadcasting it everywhere. Once the switch learns where devices are, it can forward data directly to the correct port, reducing unnecessary traffic and improving network efficiency and performance. A LAN switch follows a simple cycle to manage network traffic efficiently. A switch will learn, forward, flood, and age out. It starts by learning which devices are connected to which ports, recording their MAC addresses in a table. When data, called a frame, comes in, the switch forwards it directly to the correct device if it already knows where that device is. If it doesn't, the switch floods the frame to all ports to find the right destination. Over time, if a device hasn't been active, its entry in the table is aged out or deleted to keep the network information current and efficient. Modern LAN switches eliminate network traffic jams by giving each connected device its own collision domain and supporting full duplex communication. Each port is its own collision domain. This means every port on a switch operates independently, so data from one device doesn't interfere with another. With full duplex mode, devices can send and receive data at the same time, just like a two-lane road instead of a one-way street, allowing for faster, smoother, and more reliable network performance, which is ideal for modern high-speed data centers and business networks. Broadcast and VLANs. Broadcasts are messages sent to all devices within the same network segment. Broadcasts will stay within the same VLAN. When a broadcast is sent, it reaches all devices in that VLAN, but it does not cross into other VLANs. VLANs divide the network into groups. Each VLAN acts like its own smaller network, keeping devices organized by role, department, or purpose. This reduces unnecessary traffic. VLANs limit broadcast messages to a smaller group, improving overall network efficiency and performance. This also improves organization and security. By isolating groups of devices, VLANs help prevent unauthorized access and make the network easier to manage. Aging and filtering. Aging and filtering are key processes that help a LAN switch keep network performance smooth and accurate. As devices connect and disconnect, the switch's MAC address table must stay current. The switch continually updates its MAC address table to reflect which devices are currently active. The aging process will remove old entries. Inactive devices are automatically removed after a set time, which is usually set around 300 seconds. This is to prevent outdated information. The filtering process stops any unnecessary traffic. The switch filters frames that don't need to be forwarded, avoiding wasted bandwidth and any confusion. This also maintains network efficiency. By aging out old data and filtering unneeded frames, the switch ensures fast, reliable, and organized communication across the network. So why does all this matter? Switches direct network traffic efficiently. Ethernet LAN switches act like traffic controllers inside a data center, learning where each server is connected and sending data only where it needs to go instead of flooding the entire network. Fast and reliable communication between servers. Switching allows thousands of servers to share information quickly and reliably, reducing network congestion and keeping applications running smoothly. It is the foundation of data center operations. Ethernet LAN switching is the backbone of how data centers function, connecting all the servers, storage systems, and network devices that deliver cloud services, websites, and online applications to users around the world. In a data center, it is important that connected servers share information quickly and reliably. Ethernet LAN switching manages this flow of data by acting like a smart traffic system. Each switch learns where devices are connected and sends data directly to the correct destination instead of flooding the entire network. This process prevents congestion and keeps the data center running smoothly, powering the cloud services and applications people use every day. So the main takeaways from this presentation should be learn, forward, flood, and age out, where learning is to build the MAC address table automatically, forward meaning sending frames only where they belong, flooding for any unknown devices, ask the VLAN once and then remember it, and aging out. It removes the old entries so the table stays accurate. No collisions plus full duplex equals performance. VLANs equal organization plus security. Filtering equals less noise and more speed. These are the building blocks for everything else in networking. If you can explain how a switch makes decisions, you're halfway there in understanding layer 2 of the OSI model. If you would like more information on this topic, there are an endless number of resources that can be found on the internet. Here are a few resources I used in this presentation. Thank you.